going to be quite content heavy, so I'm going to need you to take notes. Chapter 17, we're going to move to sampling distributions. I'm going to try to fit in two exercises today. It's hard to start off because there's a lot of terminologies, but the concepts will be easy if I can get it across. Okay, so there's quite a bit to sort of walk you through, but then after that, it should be easier. Okay, sampling is meant to be quite easy, just a lot of new content, and it doesn't feel like it relates back to chapter 13, 14, 15, 16. That's why it feels a bit harder. But trust me, this is real easy. Okay, it's real easy, and you would want this to be in your exam. So here we go. The first thing we're going to have to do for exercise or chapter 17 is learn terminologies. The wording and the usage of their words is going to be important. Okay? So here we go. This is what the idea is. Think of chapter 17 is about the measure of how valid a study is. Okay, so remember when you do a study, you need to grab a group of people and you have a question. So you could say, how many people like chocolate ice cream, right? You would be calculating what the chances, if you just survey in a classroom, you would say, well, you know, about 30% like chocolate ice cream and 70% don't. Before you can make that conclusion, well, how valid is that? How valid is that study is what we're doing in chapter 17. Okay? So how we choose our groups, is determined by what we call the population and a sample. What I want you to understand is population is what we're looking at in terms of the big group. Okay, normally we like to think of population as the largest or the larger group you have. Now population can be very large, for example, all males in Australia. Okay, now if I wanted to count the number of males in Australia, I'd literally have to go to every house and every people and people outside, wherever it is, I'll count number of males. That's a very large population. Or I can make my population small. I can say number of male students in this classroom. Okay, so this is my population. If I want to make a sample is if I chose a group out of this population. So for example, our classroom, we have, I don't know, 25 students. Let's say there were 12 males, right? Then my population has 12 males. But if I chose a sample of 3, so say I choose this front row, first 3 here, right? Then now I have 1 male in this sample. But my population is our class. Does that make sense? But this is a small population. Okay, this is a small population. Whereas if I wanted to make the population larger, okay, I can say the number of students in all of Melbourne. Okay, that's a larger population. And then I can say this classroom is a sample of the larger population. Does that make sense? Okay, so sample is like you're picking out a small group out of the larger group. Okay, so if you think of it as like a Venn diagram, population is what you're concentrated on looking at. Sample is what you're taking out of it. But every time you take out of it, it could be many different subgroups of the population. Population can be a very large one, or it can be a very small one. But it does differ in terms of the methods you're going to use later to calculate whether it's small or large. But that's the first two terminologies you've got to learn. Population, sample, or samples. Does that make sense? So out of a population, out of a group, you pick out one. Yeah, so I can talk about, let's think of another example. Let's say, I can say numbers 1, 2, 3, 4, 5, 6 is my population. Okay, then picking out groups, I can do groups of 2, 1 and 2, or I can do groups of 2 and 3, or I can do groups of 1 and 3. These are your samples, if this is my population. But obviously that's a small population, that's only 1 to 6. I can make a larger population. I can say R+. That's a very large population, okay? But then I can make samples out of that. I can say, I can choose groups of 100 and 101. That's a sample. Okay, so I'm just picking out numbers from this group. So if you think of samples are the small little groups that you take out of your population, but your population can be big or small. Does that make sense? Yeah? Okay, so How does that relate to what we're going to be doing? Because that means when you calculate the probability, how valid it is dependent on how big your sample is, or how big your population is. Obviously, if I did a measure of this classroom, if I said, let's look at how smart the females are in all of Melbourne, right? That was my question. Then if I wanted to study that by taking this as my population, if I said, this classroom, let's calculate it, and I took all the female schools in my class, and then I took the average, and my average was, I don't know, let's say 99%. Then I'm like, yes, definitely women are smarter than men. Yeah? Would that be a good sample? Or would that be a valid statistic if I said that for this particular study? See, it wouldn't be because I just took one class. But this one class, how does it represent all of Melbourne? You see, because maybe Miss Duviani's class would be worse. Maybe Miss Fideli's class is 100%. We don't know. Each sample will have a different probability, and I can't use that to say, yes, all of Melbourne, clearly, my data says that all females are great. You know, that doesn't make sense. So what we're doing in our study now is we're going to learn how to find the mean, which is on average. We're going to find the variance. How bad is our error? Okay, now standard deviation. And then we're going to measure, well, how bad, like how confident can we be that our data is good? Okay, so the one that I just took, we can still make a prediction. Is this class representative of the population? Okay, and that has to have certain attributes. But to begin with, population versus sample, these are the two things you just need to know. Terminologies. Population refers to the wider community of interest, depending on whatever you want. So it could be the world, it could be our classroom, it could be just Victoria, it could be just Australia. Yeah, so population is your wider community of interest. Sample refers to the small group selected from that wider community. So that, depending on what that wider community is, choosing a small group is called the sample. Okay? Now, the example I gave here, in your slides, I said all year 12 students love HSPs, right? Halal snack packs. Now, if we conducted a research to prove this, then we would have to do a survey of all year 12 students. Now, if I said all year 12 students in Melbourne, this is a very large population, because then I have to go to every single school in Melbourne and then survey every single year 12 student and get a data of, do you like HSP or don't you? Do you like or don't you? Do you like or don't you? Okay? That would be called the population if I said all students in Melbourne, right? Whereas my sample is when I choose a particular school or a particular class. So I could take a class from Uni High. I can take a year 12 class from Princess Hill. I can take a year 12 class from Melbourne High. Those are samples of the population. Are we clear with the terminologies? Yeah, so there's only two terminologies I'm using right now. Sample and population. Next one. The question is, once you know if it's population and sample, the question is, whatever the answer I get, how valid is it? You see, one of the things we want is, we want the study to be, or the research to be fair. You can't have a fair research if I went to Viva Kebabs, people are buying kebabs, and I'm saying, I'm going to survey, and I go, do you like HSPs? And they're like, well, yeah, I do. And I go to everyone who's lining up, I'm like, do you like HSP? Do you like HSP? And then I get 100%, I'm like, everyone loves HSP, you know? That doesn't make sense, because I have to then consider, well, where am I surveying them? Am I surveying them at school? Am I surveying the school where it has access to HSPs? You know, does it make sense that the proportion of people, maybe only people who normally eat kebabs love HSPs, whereas, you know, maybe if you grew up with Indian food, then you don't like HSPs. Maybe if you're like my mom, she doesn't like dairy food. Is that a fair call if I just went to find people of my mum's group and say, do you like HSP? Do you like HSP? And they're like, no, I don't like cheese, you know? So it depends on the group that you choose, depending on the location, maybe cost. Maybe if you're really, really rich, then to you, eating HSP is very redundant. You're kind of like, no, I like to go to Vudamon, spend $600 on a meal, you know? That's what I want, not $20 or $15 on a meal. See? So then the choices the question is, well, how do you make something fair? And you want to randomly choose your population or sample to be as fair as possible. Now the name for that, okay, so another terminology, another name for that, when you choose or you make your sample size n, depending on your group, and you make it fair, it's called a simple random sample. Okay, so write that down. So there were three terminologies: population, sample. When they refer to simple random sample, they're just saying it is a fair experiment. Okay, that every person that you choose in that sample has been fairly chosen. Okay, so somehow we've randomly chosen, and normally we do that with like a raffle ticket. You know, people get a fair chance. If it's $3, everyone has, whoever has $3, they can buy it, and whoever buys it has an equal chance of winning. Okay, and the ethnicity doesn't matter, the age doesn't matter, the height doesn't matter, the weight doesn't matter. Everything is as fair as possible. It's based on your luck on a raffle ticket. That is what we call a simple random sample. The idea is we want to make it as fair as possible for every individual in the sample size n. Okay, so that's what simple random sample means. So we've got three types of vocabs there, okay, or terminologies to pick up. All right, so I'm just reading here. In particular, every member of the population must have an equal chance of being included in the sample. All right, cool. So now population, the people that we choose, every one of those group of people is fair. All right, so I'm not skewing the data, I'm not being biased about it. All right, so we've got population, sample, simple random sample. Any other questions? Because we're going to move on to the next two terminologies, and it's going to get a bit more confusing when I add on another two. Okay, so here we go. The next two. Suppose then we want to survey whether there are differences between male and female Year 12 students who love HSPs, right? Now, this is your next term. It's called the population proportion. So I want you to copy that down. Population proportion is another way of saying what's the chances of someone liking something, or the chances of something occurring, okay, for the population. Okay, so population proportion is the probability of something occurring for the population. Okay, so in our case, because my question was, was there any difference between male and female Year 12 students who love HSPs, then the population proportion, if I said it was 70%, then what I'm saying is, if I'm measuring male or female, if I measured male, then I can say 0.7 will refer to the population, which is, let's say, the school is the population. Then I'm saying 70% of us in Year 12 love HSPs. Yeah, if I said 30% for the population, then that's 30 out of the 100. Okay, so that's what a population proportion means. It just means what's the chances that you're looking for the population. Okay. Now, because when we're talking about a larger group, especially when we're talking about the whole school, if I said 30%, what I'm implying to you is that it doesn't matter how many classes you pick, Miss Fideli's class, Mr. Tran's class, or Mr. Baxter's class, I'm implying when I say the population proportion is 70%, I'm implying that if you picked Miss Fideli's class, 70% of them would also like HSP. If I said you picked out Mr. Tran's class and I said it was 70% for my population proportion, it implies that even my class, 70% of you like HSPs. Okay, so that's why it says it's constant. But this can only be assumed if the population, or N, is very large. See, it doesn't make sense if I said the population is this classroom. This is a very small population, and I said that, you know, this is 70%, therefore everyone in this school is also 70%. That doesn't make sense. Okay, this is only a very small population. If I took, let's say somehow I was able to measure everyone in Australia, and it says 70% is the probability, then you can now say, oh yeah, well, if all of Australia is 70%, then I can roughly generalize it to a normal classroom and say about 70% of you guys would also like HSPs. Okay, so that's what they mean by being constant, but it has to be when N is very large. And this is going to be key to solving things later. Okay, the fact that it has to be large and it's constant. Okay, so keep that in mind. Population proportion just means chances of that occurring. Whereas sample proportion, on the other hand, sample proportion would now mean the chances of the small group that you've chosen that it occurs. Now this is classic because you can think of like a population proportion. You can think of it as like chances of getting tails when you flip a coin. What you would tell me is chance of getting a tails is half. True? But if I took a sample, if I actually got you guys in this classroom, if I just picked someone randomly here, if I just said, Jack, flip a coin. Okay? Flip a coin 10 times. Let's see if it actually works out to be 1 out of 2. Okay? If I got Jack to flip it 10 times, he might have gotten 4 tails and 6 heads, which doesn't work out to be half, 4 out of 10. Maybe I get a mirror and I say, flip it 10 times. But the probability is not constant. You see, the probability, chance of you actually getting tails is equal to half is not constant. But when you're taking the population, it is constant. So you take a theoretical probability, you're saying if everyone was to flip a coin 1,000,000 times now, it would work out to be a half. But if I actually took out samples, each person I pick out and I say flip 10 times, it wouldn't be a half. Okay, so that is what sample proportion is. Sample proportion is the group that you take out, what's the chances of that occurring. Okay? That's why this is not constant. So the difference between the two, population proportion is constant. Sample proportion is not constant. But remember, population proportion is only constant throughout if n is very large. Okay, so just keep that in mind. So that means you can generalize to this as well. Okay, now notice the coloring or color code I've used here. I wrote denoted by P and denoted by P hat is how we pronounce it. This means P hat. P hat. These are the symbols for sample proportion. P is the notation or symbol for population proportion. Okay, so when we say P, we're referring to the population. When we do P hat, we're referring to the sample. Okay, so just write that next to each other. All right? Write in your own notes however you understand it. Sample proportion is the chances of whatever you're looking for in the sample. Population proportion is the chances of what you're looking for in a population. Okay? Now, let's cover what we just learned so far. So we've learned population, sample, simple random sample, and now population proportion, sample proportion. Yeah? Now let's add on the last two. Okay, the last two means exactly the same thing. Okay? The last two, if you're wondering what this is just how you find probability normally. So if you know the total size for the population and you know number of people who want something in your population, that's how you find the probability. And in your sample, the only difference between the two is your total number of size for sample and the number of people that you want in your sample is your probability. Yeah? So that's just your regular probability. Just know the difference between population and sample. Yeah? Now, your extra two, this only extra two is because it's in your study design and I need to teach it, but just in case you see it. So in case in the exams they use these terminologies, at least you know what they mean. Okay, so I don't know why you have to learn it, but here we go. Population proportion, which we know now is the chances, yeah? Chances of P occurring, is also known as population parameter. So you've got another name next to it. So underneath your notes there, you can write population proportion, aka population parameter. Sample proportion, P hat, underneath it write aka sample statistic. Okay, this is just your terminology for it. That's all. So there's a lot of new words coming in, but really the concept what I've just taught so far has only been two things, sample and population. That's all I really wanted to teach. Sample, population. Okay. These are just extra terms that you need to know in case they test that or in case they say that in your exam and you have no idea what a population parameter is or sample statistic. Okay, so sample statistic is the same thing as P hat. Population parameter is the same thing as P. It's just another name. Okay, and we know that when we say population parameter, it is constant. That's fair call. We're taking a very large group. We're saying it's all the same for everyone. Sample statistic, which is your sample proportion, because every group that you choose is going to be different. That's why the probability is not constant, but varies from sample to sample. Okay. All right. Now, that's your quick summary of what exercise 17A is. And what is 17A about? What are you doing in 17A? This is what you're doing. you're going to learn to determine, is it a simple random sample? So is it a fair test? So you have to use your CAS calculator and learn to test, is it a fair test or is it not? That's it. Or sometimes they give you a question and you're meant to determine the possibilities of why it's not fair. Okay? Now, if you have your CAS calculator, please grab it out and we're going to do a quick little CAS thing where we can answer some questions and try to make this as fair as possible when we choose. Okay? So here we go. In our CAS calculators, we want to be as fair as possible, right? We want to choose number of people where we don't want to be biased about it, right? Couple of notations that you can learn. What I want you to do first is type this in your calculator, because every calculator has the same default number, so you probably want to mix it up. So they tell you to start off with this first by saying random seed. You only do it once. Okay, so random seed, and type any number, any 4-digit number. They say use your last 4 digits of your phone number. Okay, and then press done. That will then just make sure that we're all starting randomly. Okay, so that we're all not getting the same numbers right now. Okay? Now, these are your 2 functions that you need to know. Oh, sorry, if you want to go through those, menu, probability, random, and then seed. And then just pick any 4 digits. Now, these are the 2 terms that you're going to be using often if you're going to do these type of questions for exercise 17A. For a random number between 0 and 1, so 0 and 1, you go menu, probability, random, and the number. Now this is what it will look like. When you just do random, you just do number, it will naturally give you a number between 0 and 1. So rand, bracket, bracket, will give you a random number between 0 and 1. Okay, so if you've done this start first in choosing a random number you can use menu 541, only works for numbers between 0 and 1. Now let's say you want to choose random numbers between 0 and 100. Is that a question? No? Okay. 0 and 100, then you can use this one. Probability random integer. Okay, integer, so you want to choose numbers 0, 1, 2, 3, random numbers to obtain 5 different ones. These are your, when you write ran int, okay, 2, 4, tells you the lower bound to the upper bound. So the smallest number is 2, largest number is 4, and you're choosing 5. So if you have a look at what I did over here, see if I don't put that 5, it will just choose a number between 0 and 100. I get 60. Rand int of 0 to 100 again, I get 3. So I'm randomly getting these numbers. It could be 60, it could be 3, whatever it is. If I put an extra comma and put a 5, it'll give you 5 random numbers. 6 random numbers if you change that to 6. So what I'm saying is this last value here determines how many you take out. Okay? Is everyone able to do that? Because we're going to do a quick problem just so you get a good feel. Okay? Here we go. Let's look at this problem here. This is your example from your textbook. It says use a random number generator to select a group of 6 students from the following class. So remember your goal, this is your class, so that's your population. We want to choose 6, but we want to make a sample where it's fair. We want a simple random sample. So how do we start off by doing it? We can close our eyes and just pick out any, but it might be unfair because you're right-handed, then maybe you choose more over here. So maybe, I don't know. Okay? The calculator has an algorithm. They will never know. So what they do is they'll say, label each of these people a number, give them a number. Okay, so if you said 1, 2, 3, you could, but we're just doing it this. We could put it in random orders, and then
cut their names up,
even better, and then just raffle it out. Now, random integer 120 to 6. You see, because I labeled them from 1 all the way to 20, random integer allows you to pick a number randomly. So you pick out a number randomly, but how many do you want? You want 6.
It repeated the integer.
That gives me 6 random. Then do it again. Until you randomly get something that makes sense.
Alright, we got it.
Got it? Good, excellent. So, So this allows you to find out the random integer. You're trying to pick out 6. The aim of this exercise, year 12s. The aim of this exercise is for you to get a simple random sample. Okay, now, what I want you to understand here is the list of names that I have here, we can call that the population. It's a small population. When I pick a group of 6, okay, in my case, when I picked out the group of 6, 5, 16, 1, 2, 19, 6, I've got these students here. This is my sample. And every one of you is going to have a different sample. Okay? That means our sample proportion is going to be different for every one of us. Okay, sample proportion for my group, I've got Sharon, Janelle, Denise, Matt, Georgia, and Mark, right? If I asked you the proportion of females to males, you can see out of my 6, I've got 4 females and I've got 2 males. So my sample proportion for females would be 4 out of 6. But your sample proportion will be different. Okay, so that's why we're saying sample proportion, or AKA p-hats, or what's the other name for sample proportion? Sample statistic. So sample statistic, we can see every one of us is going to have a different one, because you're all going to get a random 6. That's a sample. What's my population? We're all selecting from the same population, but this is a small population. Okay, so this is the large population, and this is your p-hat, which is the sample proportion. So how do you find population proportion? Population proportion, if I was talking about number of females in the group, you'll literally say out of 20, out of 20, you count the number of females. That would be constant for all of us here. So every one of us here, the female number of females in this population is the same. But our sample proportion, every one of us is going to have a different sample proportion. Is that starting to make sense? Yeah, it's difference between population, sample, population, proportion, sample proportion. Yeah? What we just did is called a simple random sample. We good? I'm just making sure everyone understands. Yeah? All right. Now, just the last question for exercise 17A, and I want to jump to 17B to finish off the theory. So, here we go. Let's read the question. A market researcher wishes to find out how people spend their leisure time. She positions herself in a shopping mall and asks the shoppers as they pass to fill out a short questionnaire, do you think this sample will be representative of the general population? Okay, so if she asks the shoppers as they pass to fill out a short questionnaire about shopping, and she went to the shopping center, the first question is, do you think this sample will be representative of the general population? Would that be a yes or no? No, because you went to a shopping mall and you're asking them about shopping, so of course it's biased because these people are shopping. Unless you're going to a shopping mall and then you ask them about something that's irrelevant to shopping, then maybe that would be, but then that's still biased because it's irrelevant to shopping. Okay, so how would you suggest that this sample could be chosen? Here I was just saying that every sample has to give everyone an equal chance. If I want to talk about shopping, it has to be randomly surveyed somehow. Okay. A possible approach is if you went to a phone directory, okay, Yellow Pages, and just randomly pick someone. We don't know if they shop, we don't know how old they are, we don't know their age, their race, we just pick out and just ask them a question, hence the call centers, okay? Makes sense why the call centers give you a call and make surveys, right? Because they need to randomly select a simple random sample, right? Now, that was exercise 17A. Was that easy? Yeah? There was only technically 3 things you learnt, or 4 things. It was proportions, sample, population, and simple random sample. Yeah? Now here we go. We've got about 10 minutes. I'm going to try to whip this concept into you. And then next session, we'll work on the exercise of 17B. This is where all your theory comes in, okay? All right, here we go. This is the harder part, so focus on this one. We know what a population parameter is, sample statistics, simple random sample. That's what I talked about for 17A. Now, this is the key in order to understand and start working on the problems, right? So now we know the terminologies. What we need to understand is when we say sample proportion, notice how we were choosing it. We were selecting people. Because we were selecting, especially the other example, there were 20 people, and I forgot how many girls there were in there. Let's say there were 16, right? If I want to know to choose number of girls out, then there are 16 girls, and let's say I was choosing 4 people out of my 20, and let's say there were 16 females and 4 males. Let's say I want to choose a sample where I have 3 girls, so female, 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 and 1 male, right? This should remind you of combinations last year when you did it in specialists. You see, you're choosing out of 20, you're picking females, you've got how many females? 16, choose 3. Out of how many males? You've got 4, choose 1. Multiply those two, that gives you the number of possible ways to find or rearrange or choose 3 females and 1 male. Okay, so it's just recapping what we did last year. Okay, and we know how to do n factorial now, or c combinations. We know how to do combinations. Okay, now what they're trying to say here is we know that a sample proportion is based on selections. This lends itself to combinations, and we've used for binomial distribution. So that's all I'm trying to say. We're using selections. So when you say you're selecting, this is how we're looking out for combinations. Now, let's take this example. A bag contains 6 blue marbles and 4 red marbles. If we take a random sample of size 4, the sample proportion for getting blue marbles can be written as... Now, before you even start this question, what I want you to understand is, what is my population? See, my population is the total number of marbles I have. Now, my population has n equals to 10. Agreed? And then my sample is what I'm choosing. I'm choosing a sample of 4. So this is my sample. Okay, so everyone's going to have a different sample. But keep in mind, this is population n equals 10. It's a very small population. When it's small, you use selections, because you can calculate the number of ways you use it. So if it's small, and that's key word. When you're in the exam, there's going to be 2 types of populations. They're not going to tell you if it's small or large. They're just going to imply it. So when they say something like this, you can tell that it is a small population. Large population is, think of like thousands. Okay, and they normally tell you, they'll say all of year 12s, all of Australians, or whatever it is. When they say that, that's a large population. In our case, you only use selections for small. So I'm going to write here small, write your notes there. Small population, we use selection. Okay? Selection. So selection was NCR. Okay? Now, my question here was, if we take a random sample of size 4, the sample proportion for getting blue. So this is me wanting to get blue. Okay, so I've got 6 blue marbles. Out of the 4, I have a choice of getting no marbles. So out of the 4, so if you think about it, this is my 4. I've got 10 of those marbles there. The sample proportion is, what's the proportion? What's the chances that a sample doesn't have any blue marbles at all? So I have red, 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 red. It would be 0 blues out of 4. Do we agree with that? Okay, so 4, I'm saying 0 blues because that's what I'm focusing on. Getting blues or I don't. So I'm getting blues, 0. Then I'd say my proportion, sample proportion, which is sample statistic, is 0. Does that make sense? Chances of getting blue in this sample. Then the chances of getting 1 blue in the sample, so 1 blue, I don't care which order it is, it could have been 1 blue, red, red, and red. Yeah? It could be like that, but I don't know what order it is yet. And that's why this is how you're going to calculate it later, because it depends on how many orders you have, right? So, this is your sample proportion for 1, sample proportion for 3, sample proportion for 2, and sample proportion for 4. But what I want you to see is it makes sense. 0%, you start from 0, your sample proportion goes from 0 to maximum of 1. Okay, and that is now talking about probability. Chances is always probability. So 0 out of 4, 1 out of 4, 1 out of 2, or 2 out of 4, 3 out of 4. What the pattern is my x variable was getting a blue. Okay, so my variable now is getting a blue. It's discrete, it's countable. So it's blue, x is blue, and to find the proportion, what you notice is it's out of your sample n. My n was 4, so it was x over n. Does this make sense, what I'm just running here? Because this is your next definition for a sample proportion. Because I'm just using this simple example here. Your proportion is x out of n. Sample proportion is based on what you're looking for out of how many you're choosing. Does that make sense so far? Yeah, I'm choosing 4 out of my 10. That's my small population. And depending on, I'm just listing out as a table. It's a distribution. 0, 1, 2, 3, and 4. Okay? Now, obviously, if we put it into a table, x is the number of blues you get. 0, 1, 2, 3, 4. Sample proportion, we've worked it out with 0, 1 out of 4, 2 out of 4, which is 1 out of 2, and 3 out of 4, and 4 out of 4 was 1. This is your p hat. True? P hat is your sample proportion, so I've got my sample proportion. The only thing I'm missing now is a probability, because once you've got a probability now, it's similar back to chapter 13 again. The question is, how do you find the chances of getting 0 blues? What's the chances of getting 1 blue and 3 reds? What's the chances of getting 2 blues and 2 reds? What's the chances of getting 3 blues and 1 red? And what's the chances of getting 4 blues and 0 reds? That's what you're looking for. Now this will link all the way back to what you did last year. These are the kind of questions you were doing. If I said, what's the probability? You have to first work out, well, what's the total number of ways where you can have 1 blue, 3 reds? Okay, that's what you want to know. That's the total number of ways for this. But then what's also the total number of ways of getting any 4? Okay, the total number, I've got 10 marbles to choose from. What's the chances, what's the total number of ways if I just chose any 4? Doesn't matter if it's blue, red, I don't care. I just want to know the total number of ways. Because remember, what's the probability? The probability of all of these depends on total number of ways. Okay, total number of ways, which is 10C4. That tells me how many I can choose totally, in total. And if I wanted to find the chances of getting 1 blue, then I know that to get 1 blue, how many blues did I have before? I had 6, but I only choose 1. And then, for every one of those that I choose, how many different ways can I choose 3 red? How many reds were there? 4. So this is number of ways that you can choose what you want. 1 blue, 3 reds. This is the total number of ways that you can choose to get anything. Just choosing 4. See what I'm doing there? But if you took number of ways divided by the total, that gives you probability. Isn't that what probability is? It's chance of what you want out of the total outcome. It's like rolling a dice. You see rolling a dice, chance of you getting a 3 out of your total possible outcomes is 6. 3 out of 6, you get half. Oh, 1 out of 6, sorry. 1 out of 6 gives you 1 out of 6. Yeah? So same thing with this one. Your job here is to find out total number of ways for this and use your calculator, or you can do it by hand to calculate sample proportion. Okay? Now, this was the part where it gets a lot tricky. You can only do this. You can only do the number of ways when the sampling of the proportion, the population, is small. So remember, what I'm doing right now only works if population is small. Okay? So, if we were to fill out the table, if you were to do it by hand using discrete probability, what you learned from chapter 13, this is the long way of doing it. So if I wanted 1 blue, so p hat means proportion of getting 1 blue out of your 4, is you have 3 reds. These are different ways you can do it. Red, 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 blue, red, red, blue, red, red, blue, red, red, or blue, red, red, red. These are the only combinations that you can get How would you work out the probability for each one? You would have done chances of getting a red, 4 balls out of 10. But if you've chosen that, getting another red is 3 out of 9 now. Times by 2 out of 8. Times by 6 out of 7. You can see this would have taken longer when the easier way was what I just showed you. The easier way that I just showed you was out of 6, I want to choose 1 blue. Times, out of 4, I want to choose 3 reds. Out of the total. See, out of the total, which was 10 marbles, choose 4. This is much quicker than doing it this way to find out the probability of a sample proportion. Do you understand what I'm trying to say there? So even if you didn't know this, you could still do it using discrete probabilities, just would have taken ages to do for every one of them. Okay, so that's what I'm trying to say. This is the shortcut in order to do sample proportion if population is small. So if you did that, still also 4 out of 35. See, if you actually did what I'm showing you, out of 4, choose 3, out of 6, choose 1, it also gives you 4 out of 35. Okay, I'm going to continue this again tomorrow, but please have a look at the PowerPoints ahead because we are short on time. That's what I want you to get a look at. Okay, we're going to test again, sample, population, sample proportion, and simple random sample. All right, thank you. I've uploaded all the PowerPoints.